Okay, welcome to the second of the EG168 video lectures that I've created this term. I just want to run through some of the ideas that we looked at in the last MATLAB lecture, just to reinforce the ideas, not to introduce anything new, but hopefully some of these concepts will help with the final MATLAB assignment. So the first thing I want to look at is the structure of a for loop, where you've got some code that you want to repeat more than once. So let's just start by constructing a vector x, and this vector x will just run from 1 up to 10. So there it is. Vector x is now just the list of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll then create a vector y and assign the value 0 to it. So I'll initialize the variable y, give it the value 0, and then let's put together a simple for loop. So the syntax for a for loop is as follows. So in this case I've created a for loop based on the variable I, and each time we run through the next section of code that I'm going to write, I will get incremented from 1 up to 10 in intervals of 1, as if scrolling through the values in this vector here that's been created 1 up to 10. So for I equals 1 up to 10, and then what we'll say is every time we come through here, I will add a number to the original value of y. Now remember, the original value of y is going to be 0 because I've initialized it at 0, and each time I'll add in the ith value in the x vector, which is up at the top here. So the first time we go through, I'll add on the value 1, the second time I'll add on the value 2, third time the value 3, and so on, just according to the number stored in the vector up here. And that's the structure. So we have to use for to start it, end to finish it, and then anything that happens between that for and that end will happen, in this case 10 times, with the value of I incrementing each time. So let's run that and see what happens. And because I didn't suppress the output by putting a semicolon on the end of that line, MATLAB has printed the value of y to the screen each time. So initially y is equal to 1, because before we entered the for loop y was 0, so the first time through we added on the first number in this vector, which you can see up here is a 1. The second time we added on 2, so it became 3. The next time we added on 3, so it became 6, and so on until the 10th time it went through that. You can see it added on 10. Okay, the second structure that I want to have a look at is the while structure, which again is used for repeating a section of code more than once. But rather than do it for a fixed number of times, as in the for loop structure, this will continue repeating a section of code until some logical expression turns false, or it'll remain repeating that code whilst some logical expression remains true. So the best way to understand this is to look at an example. So let's create the variable count and set it equal to 10, and then we'll create a while loop using the expression while. And the logical expression that I want to remain true while this next section of code repeats is while count is greater than 1. And all of the logical expressions available to you within MATLAB for this kind of thing are available to you in the lecture notes. So whilst this little bit of code is running, or whilst that logical expression is true, this next little bit of code will run. And what we'll do is every time it repeats, I will subtract 1 from the value of count. Remember, this expression here doesn't mean that count is equal to count minus 1, because obviously that can't possibly be true. What this statement is saying is make the variable count equal to the previous value of count minus 1. So you're updating the value of count from what it was here on the right hand side to what it's now going to be on the left hand side. So what this should do is subtract 1 from the value of count every time the code runs through this line here. So you can see what happens is every time you come through, the value of count decreases by 1 until that logical expression at the top, count greater than 1, is no longer true, so it's now false, and then it stops running. So the final structure that I want us to do a little bit of revision on is the if statement. So again, the best way to look at this is by doing an example. and this is where you want to execute a certain section of code only if a certain logical expression is true. So let's create a variable a and give it the value 10. So we're assigning 10 to the variable a, and we'll use the if structure. So we'll say if a is equal to 1. Okay, so in terms of logical expressions, an equals to is a double equal sign. Okay, then we'll say b is equal to, let's say, 1. Else, if a is equal to 2, we'll say that b is equal to 2. And we could repeat this as many times as we wanted. Else if a is equal to 3, b is equal to 3, or it could be any value we wanted. It could be b is equal to 30. Else b is equal to, let's say, 101. Now in this case, the code will progress through. It'll ask the question, is a equal to 1? We'll know it's not, so this won't get run here. Else, if a is equal to 2, well, it's not equal to 2, so it won't do that. Next we'll ask, is a equal to 3? Well, it's not, so it'll finally come through here, else. So if all of those things aren't true, set b equal to 101. Now because a was initially set at 10, this should come out as b is equal to 101. And again, you're going to see these ifs and else ifs and ends scattered throughout the whole of the Bloodhound program. So if you understand the basic ideas behind these kind of expressions, and also the for loop that we looked at just a moment ago, you should be well on your way to understanding what that little code is doing and how it's working.